Okay, we're ready for our second video in Shapes and Designs. This would be covering problems 1.2 and 1.3 in our textbook. This is all about estimating angle measures and using angle measures to find some missing angles. Our LEQ for this lesson is how can you use benchmark angles to estimate angle measures. We're going to start off this lesson by looking at the introductory video provided by our textbook, which is going to talk a little bit about angles and rotations using some examples from skateboarding and snowboarding.
Depending on your perspective, this either looks a little crazy or it looks like a lot of fun. Male and female athletes are flying, flipping, and spinning skis, snowboards, bikes. These events have become international spectator sports watched by millions every year. But there's more here than meets the eye. Look closely. Do you see the math? Many of the most difficult tricks involve degrees of rotation. Judges score these freestyle athletes in part by how many rotations they complete during the trick. For example, here are some 180s. And a skier throwing a 360, one full rotation parallel to the ground. And a 540 McTwist, 1.5 rotations with a twist. And check out this 720 tail whip, 2 full rotations. Wow! Rotation, rotation, rotation. Of course, another part of how well they performed is the landing.
Alright, so the first thing we need to talk about after we watch this video is just two quick definitions about what we saw. And the first one would be the definition of a rotation. And a rotation is just an angle represented by a change in direction. So the snowboarder changed his direction, he rotated, okay? And that rotation causes an angle or creates an angle. Those angles then can be measured in degrees. So the snowboarder rotates, his rotation can be marked by an angle, and then that angle can be measured in degrees. We're going to spend a lot of time talking specifically about angles, and these are things that you might already know, but let's review very quickly. The first thing, there are two important parts of an angle that we need to talk about, and those are the sides, which would be the lines, and the vertex, which is the point where the sides meet. So the two sides are rays, okay, which are line segments that end at the vertex. So at the vertex it doesn't go any farther, but then you'll notice each side has an arrow on it, meaning it extends out in either direction forever. That would be a ray. So we have two sides that meet at a vertex. Now, when we put two sides together that meet at a vertex, we obviously create an angle, and there are many different types of angles that we can talk about, most of which you've heard of before. The first one being an acute angle. Okay, that would be where the angle measures less than 90 degrees. Notice in my definition I have the words and I have an inequality statement to represent that. And you might have heard that acute angles are cute little angles. It has the word cute in it. It's small and cute. As we move up, we're going to just keep increasing our angle measure. The second type is a right angle, and you'll remember that a right angle is exactly 90 degrees. Okay, and when we have right angles, we show them by this little box in the corner, right here. That box represents 90 degrees. Without a box, we cannot assume that it's a right angle, even if it looks right. The next one would be an obtuse angle. An obtuse angle is anything that measures between 90 and 180. So it's bigger than an acute angle, but bigger than a right angle, but less than 80 degree angle, which we'll hear in a minute, is a straight angle. Okay, notice my inequality here. I have that 90 is the lower limit, x is the angle measure, and 180 is the upper limit. And these inequality signs show me that the x has to be between 90 and 180. You'll also notice down here in my obtuse angle that I have this little arrow, or this arrow that shows me which angle I'm measuring, because as we'll talk about in a minute, there's really also a second angle here that I could measure, and I have to be very careful to measure the correct angle. Our next angle is a straight angle. That is where the angle measure is equal to 180 degrees. This represents a straight line. Next, we have a reflex angle. This one might be a little bit new to you, but a reflex angle is anything that's bigger than a straight angle. So between 180 degrees and 360. Greater than 180, less than 360. Hey, notice here my arrow, it goes around the big part, because I could measure this small part in the middle. Okay, this would be an acute angle, but I don't want that. I want this big outside part, and that is my reflex angle. Lastly, I have a full rotation. That would be a complete turn, 360 degrees. Now, we can talk about some other special angle relationships. Okay? And we're going to talk about, I believe, 3 of them here. Four of them. The first one Sometimes we can put two or more angles together, like in this picture. Notice here that I have actually three angles that came together. Here's one angle, here's an angle, and here's an angle. And really, I could say that I have a fourth reflex angle here, but we're just going to consider angle 1, angle 2, and angle 3. Okay? When I put these together, one thing I can get is called an adjacent angle. Adjacent means beside. So adjacent angles are angles that share a vertex and a side. So I have two pairs of adjacent angles here. Angle 1 is adjacent to angle 2 because they share this side. Okay? And angle 2 is adjacent to angle 3 because they share this side. All of those angles share the same vertex here at S. Okay? I could get more specific with my naming conventions, and you might see this a little bit. Angles are identified by letters on their sides and vertices. Vertices is the plural of vertex. The middle letter is always the vertex. So angle 1 I could also write as OSN. Okay? Angle OSN. You'll notice goes from side O to vertex S to side N. Angle 2 I could also write as NS. I think that's an I or an L. We'll just go with an I. Okay, that would be angle NSI. And I'll go over here. Angle 3 I could also write as ISD. I go from side to vertex to side. Some more types of angles and angle relationships. Okay, let's talk specifically about when two angles are put together. Okay, so here you notice I have angle A and angle B, which are both acute angles here and here. And they come together to make a right angle. Two angles whose measures add up to 90 degrees are called complementary angles. So angle A, we would say that angle A is complementary to angle B. And I might also add down in here to prove that this is a 90-degree angle. Okay? Now, if I have two angles and this time they come together to make a straight line or 180 degrees, notice I have this angle A and this angle B, and if I put them together, I get this rotation here, which is 180. Those are called supplementary angles. Okay? So two angles whose add up to 90 degrees are complementary. Two angles that add up to 180 are supplementary. And here's how I remember that. Complementary comes before, whoops, I'm going backwards here. Complementary comes before supplementary in the alphabet. 90 degrees comes before 180 degrees when I'm counting. So complementary comes before supplementary. Right? A little easy way to remember that. Sometimes we intersect two lines, and you'll notice here that when we intersect two lines, we have created four angles here. Okay? And we can specifically talk, first of all, you should notice that in both cases, A and B, and all pairs of A and B possible, make straight angles. Okay? So there's my first kind of thing that I should notice. Right? But the special angle relationships we want to talk about here are vertical angles. And vertical angles are two angles that share a vertex but not a side. So in this case, both my A angles here are vertical, and both my B angles are vertical. Okay? And something else we know is that vertical angles are equal. So both angle A's are equal, and both angle B's are equal. And here's how I remember that. If I have two lines that intersect each other, notice how I make a V. This one is vertical to this one. They would be equal to each other. Okay, so vertical angles across from each other, sharing a middle point, a vertex, but not a side, are equal. Last thing we need to talk about in this video is estimating angles, and this is what the main point of our practice for this lesson is going to be. All right, so what we're going to use to estimate angles are called benchmark angles. Okay, and these are just set angles that we know the degree measures of and we can easily visualize to help us measure other angles. And we're going to use four benchmark angles. Okay, we start with a square. That's the easiest one to notice. You know that a square is 90 degrees. So 90 degrees would be your first benchmark angle. We can take this square then and cut it in half. If I draw an angle from one corner to the, or a line from one corner to the other, I get a 45-degree angle because half of 90 is 45. So 45 would be my next benchmark angle. I could also take this square and cut it into thirds, and that would give me a 30-degree angle like you see on the left, and a 60-degree angle like I see on the right. We can use these four benchmark angles to help us pretty closely estimate the measure of any other angle. So let's take a look at how we would do that. All right, so let's take a look here. First, at this one here. I have I have an obtuse angle. Okay, I'm not going to talk about acute angles because we just did that with the squares on the last page. Here's our obtuse angle. In order to estimate this using benchmark angles, I'm going to draw two squares right on top of it. And notice that my squares meet at the vertex of my angle. Okay, right there. So we know that this first one on the left is, if it comes up, 90 degrees. There's our square. Now the second one on the right, okay, we have to think of our benchmark angles. I like to cut it in half first. If I cut this in half, okay, that would be 45. It looks like that that's not cut in half. I can't estimate this at 45. This one here is going to be closer. It's going to be bigger than 45, so it's going to be my 60. I would estimate it at my 60. Now all I have to do is add these together. 90 plus 60 is 150. Now notice that I am using this symbol here. That is the approximation symbol, and I should really be more specific out here. And I should say that the measure of angle KLM is approximately 90 plus 60, which is approximately 150. I can't say it's exactly 150 because I haven't measured it. This angle is approximately, sorry, I'm using a new pen here, approximately 150 degrees. One more practice here. If I have a reflex angle, notice it's kind of hard to see, but I do have a dotted line that goes all the way around here that shows me that that's the angle I'm measuring. Okay, I'm going to use more than two squares here. Okay, so I start with my one square. Okay, look, I could build two squares on top of this, but I don't need to do that. I know this straight angle is 180 degrees, right? And I think that's going to come up here if I just advance my slide. Now I'm going to look at this next one. Once again, if I were to estimate this, I would say this is my 45, so it's not 45, this is less than 45. I'm going to estimate that at my 30. Once again, add them, 180 plus 30, my angle is approximately 210 degrees. There are some other ways you could do this, and you might find those out as we go through our activities in class. Okay, so this wraps up our lesson for today. As you come into class next time I see you, we're going to be answering our LAQ, how can you use benchmark angles to estimate angle measures, and that's what we're going to be focusing on by playing a little game called 4 in a row and doing some other activities where we need to estimate angle measures. Please don't forget to post your question in our class discussion board, and I will see you soon.